Welcome to Unit 5, Lesson 3, Rational Functions with Points of Discontinuity. We have a new term, and it's point of discontinuity. This is a point described by an ordered pair at which the graph of a function is not continuous, so it's just an xy coordinate. It occurs in a graph of a rational function when its function can be simplified by dividing the numerator and denominator by a common factor that includes a variable. It results in a single point missing from the graph, which is represented using an open circle, and it's sometimes referred to as the hole in the graph. Now we have an example here, graph a rational function with a point of discontinuity. So you're asked to sketch the graph of the function f of x is equal to x squared minus 5x plus 6 over x minus 3. Analyze its behavior near the non-permissible value. So non-permissible just means not allowed. Okay, so if we look at this graph f of x squared minus 5x plus 6, if you factor this top function here into x minus 2, x minus 3, you can see that we have a common factor on the top and the bottom, and these two would cancel out. That's your point of discontinuity. So x cannot equal positive 3. Now what we're left with is x minus 2, x cannot equal 3. As long as the restriction is included, so as long as you keep this point in, the simplified equation represents the same function. Now, now that you know the point of discontinuity, you can plug it back into the original equation to find what the y coordinate would be. So you have y equals x minus 2, y equals 3 minus 2, y equals 1. So our point of discontinuity occurs at 3, 1. If you're going to graph this function, you can see x minus 2 is of course just a straight line with the vertical shift down 2 units. So you know your y-intercept, and then you will also know your point of discontinuity. It's shown here by this open hole, and then you just draw your line in. In this example, we have 3 graphs and 3 functions given, and you're asked to match the equation of the rational function with the formula. So you need to analyze each of the functions and see which ones produce which graph. I think that it's easiest to look at the functions first, sort out what the factors are that are in common, and then have a look at which graph matches it. So the graph of a of x has a point of discontinuity at negative 2, 1 over 2. How did you find that? What you do is you just plug in the value of your point of discontinuity and figure out what it will equal at that point, and that will determine what your y value is. We also have an x-intercept of 0, and the only one that has that represents that function is this one. So you know that graph 2 represents a of x. In b of x, we have 2x plus 4 over x squared plus 1. You can factor out a 2 from both of these, x plus 2 and x squared plus 1 on the bottom. This is not able to be factored, and there's also no vertical asymptotes because the degree of q of x is greater than the degree of p of x. And you have an x-intercept of negative 2, therefore the graph 3 represents b of x. So because there's no asymptotes, it's really clear that b of x is represented by graph 3. In this graph, there are no points of discontinuity because there's no common factor between the top and the bottom of the fraction. And then in the bottom here, we have that parabola shape. So you know that you're going to have 2 asymptotes because we have non-permissible values x positive 2 and x negative 2. Once you see that you have that and you have the 2 asymptotes, it's clearly indicated that this would be the graph that corresponds to c of x. Next, we have some example problems that can help you to understand this content a little bit more. So on the top, we have x plus 4. On the bottom, we have x squared minus 16. So this kind of tells you that there's going to be one asymptote, one vertical asymptote for sure. And then we need to see if we'll have a non-permissible value. So you're going to factor out the bottom of the fraction, x plus 4, x minus 4. And once you've done that, you can see we have a common factor on the top and bottom. That's our non-permissible value. So wherever x equals -4, then you are going to have that open hole. And then we have that non-permissible value, the asymptote at x equals +4. So you just draw your asymptote in. We'd of course have an asymptote at y equals 0 as well. And then you just draw the general shape of your graph and make sure that you have that hole there at x equals -4. In the second example, it's much the same. Don't get thrown off by the fact that there's x cubed here. Notice that there's an x in every term, so you can start by factoring that x out. Once you do that, you're going to be left with the same thing that you have on the top, x minus 2, x plus 1. So we have 2 points of discontinuity on this graph. We have one at x equals +2, which is right here, and one at x equals -1, which is right here. So you'll just draw in those open points, find a few more points on the graph, and then just draw your general shape. Of course, x can't equal 0 and y can't equal 0. On this bottom graph, we have x over x squared minus 16. This, of course, can be factored into x plus 4, x minus 4. So we will have vertical asymptotes at those two values, here and here. And then the graph of this one's a little bit of a weird shape. You're going to have one side going down here, one side going up here, and then through the middle you're going to have 0 with a multiplicity of 3. So in this section of the graph, y can equal 0, but outside of it you're going to have two functions that don't touch 0. So here asymptotes, here asymptotes, here it's going to go through the middle, right through 0, 0, and down. You just pick some key points on your graph and plot them. If you're confused about this, you can use that app Mathway and plot this. And when you go into the options menu, when you press enter on the equation, you can say find the zeros of the graph, and then it will also produce you a graph to see what it looks like, and that will really help you to plot out some points. Now, of course, another option here is to use some mapping points. You can just plug in a value in any of these. What does it equal when x equals 1? What does it equal when x equals 10? That's another way that you can plot the graph as well. Beyond this, you have some practice questions, and then you can continue on to the homework for lesson 3.